everyone. Today I want to show you how to create a narrow FM with a frequency list receiver blocks. Like here, this is a simple software with 15 blocks. Like here, today I want to show you how to create these step by step. As you can see here, this narrow FM frequency list receiver, I have eight lists here. Channel 1, channel 2, 3, 4, blah 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 to channel 8. And here in this block I will put the frequency list I want to monitor in narrow band for testing. As you can see here, I put 446.1 megahertz, 446.2, 446.3.4, blah 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 to 446.8. And I rename it as the channels from channel 1 to channel 8 from here, from this blocks WX GUI chooser. Now I select, I run the software and select channel 1 for testing. Right now let's put it here, 446.1. Let's, as we can see here, this testing right now. 1 2 1 2 testing. As you can see, 1 2 1 2 1 2 testing, 1 2 testing. Channel 1. Let's try channel 2. 446.2. Let's try without put to channel 2. It's appear in spectrum, but you don't hear anything. Let's choose channel 2 here. So let's try into this. As you can see, this is Mike Whiskey Kilo, this is Mike Whiskey Kilo, testing channel 2, testing channel 2, over. Right now let's try channel 3, 446.300. As you can see here. Right now let's put in channel 3 here. Let's try testing. This is Mike Whiskey Kilo, testing channel 3, 446.3. As you can see, it's working to channel 8. You can put which frequency you want to monitor in narrow FM, so it's easy. Watch me right now how to build this easy narrow FM receiver with the frequency list. Okay, let's go into next part, how to do it in GNU-RADIO Companion. Okay, let's start GNU-RADIO Companion. Okay, now new. WX GUI. Let's rename it like narrow FM freq list receiver. This title, let's title it as a narrow FM freq list. Let's title it as a narrow FM freq list receiver. And this and blah blah blah. Okay, now let's put the variable sample rate here and make it 2E6. So 2 megahertz, the sample rate. Okay, now we need another variable. Let's define it as a down rate. And let's make it as a 250 E3, 250 kilohertz. Okay. Now we need a WX GUI chooser. Let's define it as a tuner. Let's name it as a, label it as a station select. And let's make a default value, as you can see in my first video here. I will put it, let's put it for testing as a 446.1 to 446.8 and make it 8 channels. You can put what frequency you want. So I am doing it 446.1 as a default value and put it in channel 1 the same, and make it to the channel 8 with 446.1 to 0.8. So you can put here what you want. So let's put here 446.1 E6, the default value, and let's make choices here from 446.1 to 446.8. So let's put it here like this. As you can see, 446.1 E6 and comma, and another 446.2 E6 and 0.3 and 0.4, and the labels here, let's put it from channel 1 to channel else. You can label it what you like, as you can see here, from channel 1 to channel 8. So the channel 1, it's 446.1 E6, channel 2, it's 446.2 E6, channel 8, 446.8 E6. Okay, now let's make the type is radio buttons and make it horizontal. Okay, now we need the RTLSDR source. Let's put it here. Okay. Okay, now as you can see here, the sample rate is sample rate. The channel 0 frequency, let's label it as a tuner that we define here from WX GUI chooser. So when you choose, you change the channel 0 frequency from the RTLSDR source block. So let's change it to tuner source from here that we defined before. Okay, and the channel 0 frequency correction PPM is 0, You can here change it from a frequency correction ppm from your SDR. If you have a cheap SDR that have a ppm correction like a plus 15 or plus 10, you can put it here to make accuracy when you got the signal. And let's make a channel 0 offset mode here. Let's make it automatic. And the channel 0 IQ balance mode, let's make it automatic. And the channel 0 gain mode is manual. And the channel 0 RF gain, let's define it as RF gain because we want to make a RF gain a block. Let's define it as a RF gain. Okay, and 2020 and 0. As you can see here, we have a red error here because we not define RF gain. Okay, now let's define RF gain. Let's choose a WX GUI slider. So make a slider here for the RF gain. After that, we put the RF gain block. This red here, it will disappearing. So let's get a WX GUI slider. Let's put it here. Let's define it as a RF gain. And let's label it as a RF gain. Let's put the default value when you start launch the application, the software. Let's make it default value 15. It's good, I think. The minimum 0 and the maximum, let's put it for 45. And the number of steps, let's make it 12. It's enough because it's RF gain. And the style horizontal and the converter float, let's make it integer. Okay, and let's make the grid position as a 1 0 1 4. Okay, as you can see, the red line here is disappearing because we defined the WXGU slider ID as RF gain. Okay, now we need another WXGU slider for a volume. Let's define the ID as a volume and let's label it as a volume. And the default value, let's make it full 100 and the minimum 0 and the maximum 100 and the number of steps 100, and let's make it the style is horizontal, good, and the converter is a float. And the grid position, let's make it 1 5 1 8. Okay, okay, now we need a WX GUI FFT sync. Let's put it here. Okay, let's title it as a sampling band pass. and the sample rate is sample rate, and the baseband frequency, let's make it as a tuner that we define. And here the Y dives is 10 and 0, 2, and the 50 size 1024, blah blah blah, everything is correct. Okay, let's put it here. Okay, now let's make it from the RTL source out to WX GUI FFT sync in. Okay, now we need to create a block low pass filter. The ID is low pass filter 0, and the FIR type is complex decimating. And now the decimation, let's make it INT sample rate with the down rate. Let's make it INT samp rate down rate. Let's close it. Okay, the gain, let's make it 2. And the sample rate is sample rate. And let's make a cut-off frequency as a 50 kilohertz, 50 E3, and the transition width, let's make it 10 kilohertz, 10 E3. And the window, let's make it Kaiser, and the beta is okay. Okay, you can see the sample rate is 2 megahertz and the cutoff frequency 50 kilo, and the transition width is 10 kilo. Okay, now let's take from RTL source out to low pass filter here. Okay, now we need a simple squash block. Let's put the threshold here is -30 and make the alpha is 1E -4. Let's connect from low pass filter out to simple squash in. Okay. Now we need the FMD mode block. Just define it channel rate as a down rate that we define before here, down rate as you can see. And the audio decimation, let's make it 1, and the deviation is 75,000 here is good, and the audio pass is 15,000 good, and here the audio stop at 16,000, and the gain is 1, and 2 is 75 E-6. Okay, let's take it from simple squash out to FMD mode in. Now we need a rational reassembler block. put it here, and let's make sure the type is change it to the float real tabs, and make sure the interpolation is 24 and the decimation 250, and let's connect from the FMD mode block out to rational reassembler in. Okay, now we need multiply const block. Let's put it here, and make sure that to change the IO type to float, and the constant, let's make it for a volume. So let's type volume 100, and the VIC length is 1. Okay, so let's connect it from the rational reassembler out to multiply const in. Okay, now we need audio sync. Let's put it here. Let's make the sample rate 24 kilohertz, and the number of inputs 1. Let's click OK, and let's connect from the multiply const block out to audio sync block in. You can see. Now finally we need WX GUI FFT sync. Put it here. Make sure to change the type to the float, and the title let's title it as a D mode out. And the sample rate, let's make it as a down rate. Okay, the Y per div is 10 dB, and this YDV 10 blah blah blah. Everything is correct. Okay. Now let's make it from the rational reassembler out, going to WX GUI FFT sync in. As you can see here, it's a 15 block. Everything's correct. Let's save it to desktop. Let's rename it as a narrow FM freq list test. Okay. Okay, now let's click here to create a Python to generate the flow graph here. As you can see here down, the narrow FM frequency list PY is created. So let's start it. As you can see, it's working right now. Let's try to testing channel 1 446.0 1.1. So let's see if I hear the channel 1 in my PC. This is Mike Whiskey Kilo testing channel 1 over. As you can see, it's working. Let's try channel 5. So I define channel 5 as a 446.500. This is Mike Whiskey Kilo testing channel 5 over. As you can see, everything is correct. So it's easy tutorial how to create your own narrow FM frequency list receiver under Windows 10 using GNU-RADIO Companion. It's easy to build, just 15 blocks. Just follow my video step by step to create your own frequency list. Okay, YouTube, this is Canfer here. Thank you for watching and stay tuned for another video on GNU-RADIO Companion 73. Bye bye.